of a presentation by the Communication and Education Working Committee of the EMV Migration Forum, Contact Chip Card Online Authentication. The purpose of this presentation is to provide a visual, non-technical overview of how an EMV transaction is secured through the creation and validation of cryptograms during an EMV transaction. First, some assumptions. This authentication method is applicable to debit, credit, and prepaid chip card transactions. The data fields and sample data elements depicted throughout this presentation do not depict the specification of any particular network. Specifically, the number of data fields are reduced here for simplicity. The cryptographic operations are simplified for educational purposes, and the method depicted here is very general and is only one authentication method available to an issuer. Deployment of this or any other authentication method by a given issuer will depend on applicable regional and regulatory requirements. There are three basic steps in every EMV transaction. One is authentication, which validates that the chip and issuer involved in the transaction are authentic and not counterfeit. Second is verification, which validates the cardholder's involvement in the transaction. And third is authorization, whereby the transaction is approved or declined. What we're going to talk about in this presentation is the online method of authentication. And think about this in four main steps. The first two steps take place in the authorization request, which is where the cryptogram is created by the chip and then later validated by the issuer. And then in the authorization response, the issuer creates the cryptogram, and that cryptogram is later validated by the chip. And it's through these four steps that an EMV transaction is made very secure. And we will talk about each of these four steps during this presentation. First, we'll start basic by saying that the issuer personalizes many EMV chip cards. And each chip card has a unique cryptogram key, which is embedded into the chip and stored securely by the issuer. We'll take a closer look at one of these chip cards. We'll see that it's personalized with the same data that's embedded into the magnetic stripe, but it also includes some additional EMV co-specified data, such as the cryptogram key. When a chip card is inserted into an EMV-enabled terminal, there is data that's associated with that specific transaction from both the card and also the terminal and transaction. The chip will utilize certain card data and certain terminal and transaction data to generate a unique cryptogram. Here's an example of a cryptogram. This cryptogram is then included in the authorization request. Please note, though, that the cryptogram key is not included in the authorization request. We've drawn a line through it there, and it will disappear in the next step. But first, I'll call out one definition, and that is the ARQC, which is the authorization request cryptogram. That is the industry term for this value, and we'll use that term throughout this presentation. So now we'll see the cryptogram key disappear, but the remaining data elements will be combined into the authorization request. And that authorization request is then sent to the issuer. And at this stage, the issuer wants to validate the authenticity of the chip. So let's look at the data that the issuer has received. The cryptogram key field is blank. So the issuer will use known card data to populate that cryptogram key. It will then use certain card data and terminal and transaction data to generate its own unique cryptogram. We can see the example of the cryptogram here. This cryptogram is then compared with the ARQC that was generated by the chip and received in the authorization request. If the values are identical, the issuer knows that the chip used to initiate the transaction is the authentic chip it issued with its unique cryptogram key. If the values do not match, the issuer should decline the transaction because it knows that the chip contains an incorrect cryptogram key and is likely a counterfeit. The steps we've talked about thus far have authenticated the chip. The remaining steps are focused on the issuer authentication, and they are not required by payment networks in the United States. The first step in this process is for the issuer to generate a response code. In this case, the issuer is going to approve the transaction. The issuer will then utilize the cryptogram key along with the other data elements to create a new cryptogram. And this cryptogram is going to be different than the first cryptogram because different data elements were used to generate this cryptogram. This cryptogram becomes known as the ARPC. It becomes part of the authorization response message, and the ARPC stands for the authorization response cryptogram. That's the industry term for this value. At this stage, the cryptogram key is not included in the authorization response. Also, the ARQC is not included in the authorization response. The chip already knows both of those values, so there's no reason to communicate them back to the chip. So they'll be removed, but the remaining data elements will be included in the authorization response, which is then returned to the point of interaction between the chip and the terminal. And at this point, the chip wants to validate the issuer. So let's look at the data that the chip received. There's two data values there. The chip will populate the ARQC and the cryptogram key. It already knows these values. It will then utilize these new values to generate a new cryptogram. This is known as the chip-generated ARPC. It will be compared with the ARPC received in the authorization response. If the values are identical, the chip knows that the authorization response is from the authentic issuer because the chip's cryptogram key is only known by the issuer. At this point, the transaction is fully authenticated. In reality, this process occurs almost instantaneously. So I really want to thank the project team that helped to put this presentation together. Our goal was to make it simple and educational, and we hope that we achieved that goal. I also want to talk quickly about the EMV Migration Forum, which is a cross-industry body focused on supporting the EMV implementation steps required for global and regional payment networks, issuers, processors, merchants, and consumers to help ensure a successful introduction of more secure EMV chip technology in the United States. There's a website shown there. We'll include that website in the description of this video. And at the bottom of the page, there is an email address. We invite you to share your comments or recommendations for edits with us using that email address. We'll also include that in the description of the video. So hopefully this presentation achieved our goal of demystifying the creation and validation of cryptograms to secure an EMV transaction. Our primary goal within the Communication and Education Working Committee is to educate stakeholders and consumers on concepts related to EMV. So if you found this to be a useful resource, please feel free to share with others and let us know if you have feedback using the email address we provided. Thank you.